In solving one-step equations, you only have to undo one operation. And we're going to now move to where you have to undo two operations. And basically, we're going to follow the order of operations in reverse while undoing these operations. But let's first look at the way it would work if we were to use backtracking. Let's take the problem 2x minus 6 is equal to 14. Okay? So if I was to use the backtracking method, first I would set up the flowchart. So I'd start with x, and I'm going to multiply by 2, so that would give me 2x. And then I would subtract 6, and when I subtract 6, that would give me 14. Now I'm going to backtrack. So I'm going to go back this way. So instead of subtracting 6, I'm going to add 6. So when you backtrack, you're undoing the operations. So when I do that, 14 plus 6 is going to be 20. And then instead of multiplying by 2, I'm going to divide by 2. So 20 divided by 2 is 10. So x would equal 10. That's using the backtrack method. But let's look at it using the equality properties. So if I had 2x minus 6 is equal to 14, I'm going to undo the operations, but I'm going to kind of do it using the order of operations in reverse. So I'm going to do all my adding and subtracting to both sides first, and then I will do all my multiplying and dividing both sides. So I'm going to start with adding 6 to both sides. And when I do that, I get 2x is equal to 20. And remember, the whole goal is to isolate that variable. So I'm just undoing these operations in order to make that happen. So now I'm left with 2x is equal to 20, which is just a one-step operation there, one-step equation. So instead of multiplying by 2, I'm going to divide by 2. So that will leave me x is equal to 10. So you can see I get the same answers, but here on the left I'm using the backtrack method, and over here I'm using the equality properties. Let's do a couple examples here where we're going to be using the two-step equations, solving two-step equations. So let's do a problem like this. X over 3 plus 13 is equal to 11. So the first thing I want to do is subtract 13. Instead of add 13, I want to subtract 13 and do it to both sides. So that will leave me x over 3 is equal to 11 minus 13 is negative 2. Now, to isolate the variable, I'm going to multiply by 3. So instead of divide by 3, I do that to both sides, and that leaves me x is equal to negative 6. Let's work on another problem. Let's say I have negative 9 minus y over 7 is equal to negative 12. Now, I have y divided by 7 here, and I'm taking that away from negative 9. So the first thing I want to do is get rid of this negative 9. So remember, negative 9 is the opposite of 9. I could add its opposite to make it 0. So the opposite of negative 9 is positive 9, so plus 9. So negative 9 plus 9 is 0. Now look, it leaves me minus y over 7. Right? But since I added 9 here, I have to add 9 here as well. So that will give me negative y over 7 is equal to negative 12 plus 9 is negative 3. So I have negative y over 7. So what do I multiply both to get y by itself? I'm going to multiply by negative 7. Because remember, I can put that negative sign either in the denominator or numerator. And let's put it in the denominator so that way I'm canceling out right there. So equals -3 times -7. So these cancel, leaving me just y. So y is equal to -3 times -7 is +21.